Problem number 21. Two pulleys as shown in the figure are made of the same metal with density ρ. Pulley A is a uniform disk with radius r. Pulley B is identical except a circle of r/2 is removed from the center. When two boxes M equal alpha M, where alpha greater than 1, are connected over the pulleys through a massless rope and move without slipping, what is the ratio between the accelerations in system A and B? The mass of pulley A is big M plus small m. Solution. Let's do common case. Suppose that we have two masses with a different mass, and we have pulley with a moment of inertia I and radius r. So for this system of two masses and pulley, we have three equations. Two equations for motion of small mass and big mass. Big mass equal alpha small m, and third equation is for rotational motion of our pulley. I, that's moment of inertia, beta is angular acceleration, and this is torque from these two forces. Suppose that I equal this expression. Here 1 plus alpha small m, that's total mass of this pulley. R is radius and gamma is coefficient, which is different for two cases. The solid pulley and the pulley with a hole. We will count them later. Because motion of this rope is without slipping, we have angular acceleration beta equal linear acceleration A over radius r. And now we can insert this I and beta to third equation for rotation. Instead of third equation, we have this equation. Now, to count what is acceleration, we need to add first equation, second equation, and this one last equation to cancel on all tensions. So finally we have this equation from which we can count what is acceleration. Finally we have expression for acceleration in both cases, which depend only of gamma. And now we can write what is the relation between A and AB. For this relation we have this expression, which is depend only of gamma for both pulleys. Let's count gamma for case A and gamma for case B. Let's say mass of pulley equal m. In that case, for solid disk we have IA equal 1/2 mr square and gamma A equal 1/2. In case of pulley with a hole, we have to subtract moment of inertia of this hole, which is was taken from this pulley from initial I. That will be this expression, where this number is just I for this taken part of pulley. Finally we have gamma B equal 15 over 32. And after all calculations we have a relation between acceleration is 47 over 48. Problem 22. A body of mass big M and a body of mass small m, much less than big M, are in circular orbits about their center of mass under the influence of their mutual gravitational attraction to each other. The distance between the bodies is r, which is much larger than the size of either body. A small amount of matter delta m much less than small m is removed from the body of mass small m and transferred to the body of mass big M. The transfer is done in such a way so that the orbits of the two bodies remain circular and remain separate by distance r. Which of the following statements is correct? Solution. Let's check statement A. The gravitational force between the two bodies increases. Let's count this force. This force equal to G small m multiplied by big M over r squared. In second case, when we remove small delta m from small body added to big body, we have force F2, which is equal this expression. Now we just need to compare m and big M with this amount. So let's count what is this expression on the top. If we check this expression, we see that we have m multiplied by big M. That's the same as in previous force, but after that we have all negatives, because big M greater than small m, we have this expression, which is finally less than this expression. So it means that force F is greater than F2. That means that force F1 greater than F2, and statement A is not correct. For the same reason, statement B, the gravitational force between the two bodies remain constant, is not correct, because it's less than initial. Let's check statement C. The total angular momentum of the system increases. First, we have to count where is the center of mass of this system around which both bodies going by circular orbit. So, radius of the big body will be this one. And now we can count what is the speed of this body. We have a centripetal force, which is big M v square over r. That's equal to gravitational force between two bodies. And from here we can count what is v. And the speed of this big mass equal this expression. And the angular momentum for big mass equal big M v r. And after this insertions we have this expression. By symmetry we have angular momentum for small m equal this expression, and after all we have total angular momentum equal this expression. Here we have m plus m is constant, but we already found that small m multiplied by big M will decrease in case of removing delta m from a small mass to big mass. It means that either C or D are not correct, because angular momentum for system will decrease in any case. Let's check E. The period of the orbit of two bodies remains constant. We have a period equal to pi r over v. And now we can insert this expression here. After all, we can count what is period, and that will be this expression, which is constant when m small plus big M is constant. So it means that answer E is correct.